Again, I'd like to welcome everybody to our training session this morning. This morning, we're going to be doing an overview on the HMH7, our 17 SEER horizontal discharge heat pump. And what I typically do at this point, team, as well, is I go ahead and shut my camera off because that allows it to stream a little bit better for the PowerPoint. So I'm going to go ahead and shut off my camera at this point, and then we'll go ahead and pull up the PowerPoint presentation here for everyone. Okay. And William, I see that you are muted, so that's perfectly fine. One of the things I'd like you to do, though, if you do have those good questions, please just unmute yourself and ask those questions, then mute yourself back up. And then what we'll do is we'll be sure and get those questions answered for you on a recorded session this morning. So starting out this morning, taking a look at our PowerPoint. Give me just a quick thumbs up or whatever, William, or unmute yourself quick. Can you see that first slide? Can you see that first slide?
Yes, everything's good.
Okay, that sounds real good. Thank you. Okay, team, at this time, please remember our HMH7 17 SEER heat pumps are a horizontal discharge unit, as you can tell by the picture, the front screen right there. And you'll notice on the left-hand side, the larger unit, that's going to be the 4 and 5 ton platform with 2 fans. The 2 and 3 ton platform will be the single fan unit that you see on the right in the picture right there. One of the things we'd ask you to please remember also, the unit service fittings are going to be 5/16 flare fitting, and an adapter will be required to adapt the 1/4 inch service hoses that the technicians have on their manifold set to that 5/16. Now, these little adapters, they're readily available. Fact is, a lot of the guys probably have them already because it's the same type of fitting that they use when they work on mini splits. And so Robinair or Yellow Jacket, there, several companies make them, but just remember it's 5/16 on the unit down to 1/4 inch on the on that adapter for the manifold hoses that the technician uses on their service gauges. A couple other things, we went ahead and we made a little revision on the program about a month or so ago, and one of the things that we had from some of our training sessions, some questions we had were specifically, what are the minimum maximum temperatures that are that these units will operate? So I went ahead and put this little chart in here. As you can see, the minimum temperature for cooling outdoor in the cooling mode of operation, minimum temperature for cooling from the factory is 35 degrees, dry bulb heating is -5 degrees is minimum. And then on the indoor coil, the minimum wet bulb temperature is 57 on the indoor coil, and dry bulb heating minimum would be 50 degrees. And then maximum outdoor cooling temperature is 122 degrees Fahrenheit. So William, that may impact you a little bit out there in your market area because it gets pretty warm out there where you are. So just so you know, from the factory, it's 35-degree cool and 122-degree maximum temperature is the standard temperature for these min-max. And then on dry bulb heat, in the heating mode of operation, the maximum temperature that this thing is designed to heat for heating mode is 75 degrees outside. And then the indoor coil, wet bulb cooling is 72 and dry bulb heating is 80 degrees. So just kind of keep in mind that, if a homeowner is wanting to heat and it's 75, if it's above 75 degrees outside, the unit will default into a fault mode if it's warmer than 75 outside and you're calling for heating mode of operation. And then again, 122 degrees, it has some safeties built in at 122 degrees outdoor temperature. So we always recommend that these units be, if you're in a warm area of the country, make sure and put them in a shaded area if at all possible, where you're going to have some shade, and that'll help reduce that outdoor maximum temperature. Any questions or comments on this so far?
No, I think it looking good.
Okay, real good. Thank you. Okay, so the first thing we're going to talk about, we're going to be discussing the low voltage wiring and setup of our heat pump with an AE air handler. And this is going to be featuring just a standard ECM motor. So the AE air handler is a high efficiency, what we call standard ECM motor. It's a high efficiency motor, but we refer to it as the standard ECM motor. Now, some contractors will remember back where this type of motor was called an X13 type of motor. So the X13 was actually a previous generation of the standard ECM motor. There are some enhancements in the standard ECM motor, and so we relabeled it from X13 to standard ECM motor, and we did that a few years back. Now, one of the things I'd like to remind everybody that on the low voltage wiring with an AE air handler, it's going to be just a simplified block wiring diagram we're going to be talking about. We're going to literally be going over the block diagram wire for wire. The other thing is the AE air handler has no physical screw-on terminals, but it's equipped with pigtail connections. So remember these connections that we're looking at, even though the block diagram that we're using, it's showing it go into like a terminal. Just remember that the AE air handler, those connections are actually going to be in a wire net because they're pigtail connections. In addition, we're going to be discussing the wiring of the accessory single pole double throw relay in the indoor unit and how it's used for airflow reduction. Now, kit number HMH7AK001 is recommended for convenience and the supplied parts. It should be noted those supplied parts are going to be a little board with a relay on it. In addition, it'll have some wiring as well as a bi-flow filter dryer in the kit. So this kit is recommended because it gives you basically everything you need to hook it up. It should be noted that the HMH7AK002 relay kit may be used. However, one of the relays on that board will not be needed for this application. So just kind of keep in the back of your brain, the HMH7AK002 kit will be used for variable speed products. Variable speed products. If you have a variable speed air handler or a variable speed furnace, you'll have to have the 002 kit. However, on the AE air handler, you could still use the 002 kit. It's just that you will not utilize one of the relays on it. So the recommended kit for the AE air handler is going to be the HMH7AK001 kit because it just has the single relay on there. And that's kind of the difference between those two kits. The 001 kit just has a single relay on the little relay board, and the 002 kit has got two relays on it. And again, I want to stress that if you can't get the 001 kit, you could still use the 002 kit. You just wouldn't use one of the relays on that 002 kit with the AE air handler. In addition, heat pump thermostat. This is a standard 24-volt thermostat. So basically use your favorite heat pump thermostat, whether it's a Robert Shaw or a Honeywell or White Rogers, whatever your favorite heat pump thermostat is. It's just 24-volt conventional thermostat for this hookup. But that heat pump thermostat has to have the BO selection. So make sure that it has the BO selection for reversing valve operation, because our HMH7 17 SEER horizontal discharge heat pump is going to be energizing the reversing valve in the heating mode. That's the B terminal, the heating mode. It's different than any of our other Champion products. It's not bad, it's just different. But please remember, we're going to be energizing the reversing valve in the heating mode of operation on the HMH7, whereas all of our other Champion heat pumps, we energize the reversing valve in the cooling mode with the O terminal. So this is the exception. We're going to energize the B terminal for heating with this heat pump. Any questions or comments so far before we get into our block diagram?
No, I think it's working out pretty good. Thank you, Joe.
Okay, good. Thank you. At this time, team, we're going to take a look at our wiring diagram. And again, this is just a simplified block diagram. We're going to go literally wire for wire from the thermostat on the left to the indoor unit. Now, remember that indoor unit, that AE air handler has pigtails on it. And we're featuring a two-stage heat strip today in that air handler. Now, if you only have a single-stage heat strip, you just use the W terminal. But if you have a two-stage heat strip, you'd have a W1 and a W2 wire or pigtail. So we're just going to feature a two-stage heat strip today because that should cover all bases. And then, of course, the outdoor unit, you're going to have some terminals outside, B, S1, W, Y, and C outside. So let's start taking it wire for wire. So it's real simple. The B terminal from the thermostat is going to go straight outside. It doesn't even touch the indoor air handler. And remember, we're going to energize the B for reversing valve operation in the heating mode of operation, So the thermostat that you select, it has to have a BO selection so that you can energize the reversing valve for heating mode. W2 is our second stage auxiliary heat. That'll go from the thermostat to the indoor unit. W1 is going to be our first stage auxiliary heat, and that's going to go from the thermostat to the indoor unit and then outside. Now remember that W outside is going to energize that first stage of heat strip during defrost mode. That's why we have to carry that wire outside to W outside. So W1 on the thermostat to W1 or the heat strip inside, first stage heat strip in this example, to W outside, because during defrost we want to energize the heat strip during defrost. Because remember, team, anytime you take a heat pump and you put it into the defrost cycle, it's actually putting it into the cooling mode of operation, the cooling mode. So we don't want to freeze the homeowner out in the cooling mode in the middle of the heating season. So we bring on that auxiliary heat during defrost for that purpose. Y terminal from the thermostat is going to go straight outside. Now this is our compressor call. Now please note that there could be, if it's so equipped, it could be a factory yellow wire on the motor. So if you have a factory yellow wire on the ECM motor, the indoor blower motor, go ahead and remove that, because we're going to be dealing with some other terminals here a little bit on the motor. So if you do have a Y or a yellow factory installed wire on the ECM motor, go ahead and just remove that, because we're going to be doing some different things with the motor here with that relay shortly. So Y is our compressor call from the thermostat. It goes straight outside to Y to the outdoor unit. C is our 24-volt common, and that goes all the way through. When I say all the way through, we go from C terminal on the heat pump to C terminal on the indoor unit. And remember, that's a pigtail. You're going to be making this up in a wire nut. To C terminal outside, this is our 24-volt common connection. R terminal from the thermostat, this is our 24-volt hot connection from the thermostat. Now, please note, it does not go outside. I want to stress that one more time. This is a little bit different than our other products. Our terminal does not go outside because the outdoor unit has its own function as far as powering up or utilizing the low voltage terminals outside to power its board and to power its functions up outside. So we do not take 24-volt hot or R terminal outside, because the outdoor unit doesn't need that function of 24-volt hot going outside. So please remember that our terminal strictly goes from the thermostat to the indoor unit. G terminal will be our fan call. So anytime the heat pump thermostat calls for fan operation, it will energize the G terminal or the green wire. Remember, it's a pigtail on the AE air handler. You'll energize that G terminal for fan operation. Notice on our relay, we have our 001 kit relay, and that little single pole double throw relay we're looking at right now, the B terminal of the relay coil goes to S1 to the outdoor unit. Now, so what's going to happen is the S1 output on the outdoor unit will actually operate that relay, and we'll see that in a little bit. We'll look at some animations to show you how that works. So one side of the coil, one side of the relay coil, in this example we're utilizing B, one side of the relay coil goes to S1 terminal outside. The other side of the relay coil, in this example, it's labeled A. The other side of the relay coil goes to 24-volt common. So just tie that into the 24-volt common connection for the other side of the relay. So as you take a look at it right now, you'll notice that S1 is actually going to operate that relay, and that is correct. The S1 will be an output for airflow reduction. So A and B will be utilized at this point on the relay coil. A, one side of the coil goes to 24-volt common, B goes to S1 outside. Now watch this. common terminal on the switching relay itself, the switching contacts, the common terminal will be tied into our Y connection going outside. So anytime we have a compressor call, or compressor operation, Y terminal, we'll feed power to the common switching terminal of the relay. Now on the ECM motor, we're going to take and we're going to bring a W1 and we're going to hook it up to the ECM motor, and we're going to select high speed tap on the ECM motor for W1 auxiliary heat call. Now this is very, very typical. And so basically anytime we have a heating call, anytime we have an auxiliary heat call, in other words, when the heat strip comes on, we're going to take that ECM motor to high speed. And that's for safety, but it's also to make sure we don't, burn up the heat strip and all that stuff. But that high speed tap, now this is typical. Now, of course, the contractor could select a different speed tap if he wanted for auxiliary heat call, but just make sure that you check your airflow and make sure that you're not overheating that coil or the heating element and so on. But typically W1 from the thermostat on the heat strips will go down to the high speed tap on the ECM motor. You'll notice that on the relay, we've taken a wire from normally closed NC, the normally closed connection on the relay, and we're going to go over to the ECM motor and we're going to select a speed tap on the ECM motor to provide 100% cooling airflow. So the normally closed contact on that relay is going to go over and we're going to select a speed tap on that ECM motor for 100% cooling airflow. Now please write this down, or please remember this. We always want to make sure we set our airflow up on our indoor air handler. We want to set it up for 400 CFM per ton of cooling. So in other words, if I have a 2-ton unit setting outside, this 100% cooling airflow tap, we want to select an airflow tap on the ECM motor to provide 800 CFM in that example for a 2-ton unit. If we had a 3-ton unit setting outside, we'd have to set that up for 1200 CFM and so on. So we always want to select our speed tap on our ECM motor with this normally closed contact on the relay to provide 400 CFM per ton of cooling capacity. And so this is our 100% airflow tap. Any questions or comments so far about the low voltage block wiring diagram?
Now we're looking good, Joel.
Everybody good? Okay, thank you. All right, so then what we're going to do is we're going to select on the normally open contact of the relay, the NO, or the normally open contact, we're going to go over and we're going to select a speed tap on the ECM motor to provide 60 to 65% cooling airflow. So what happens is when that relay switches, we're going to reduce the airflow on the ECM motor from 100% to about 60% airflow. So again, in our example, if you have a 2-ton unit outside and I have 800 CFM for cooling, for 100% cooling, 60% of that would be about 480 to about 500 CFM, something like that on a 2-ton unit. So remember that normally open contact on that relay, you're going to have to select a speed tap that's going to give you about 60 to 65% of your cooling airflow. So you're going to have to select a speed tap. So let's give an example. So let's say, for instance, 100% cooling airflow, maybe we landed on speed tap number 4 on the ECM. Well, this normally open contact, it might be on speed tap number 2, it might be on speed tap number 3, it might even be on speed tap number 1. So we have to make sure that the contractors understand, all you guys, when you're setting up the air handler, you're going to have to measure your airflow, and you're going to have to make sure and set up your normally closed contact on the relay for 100% airflow, and then measure your airflow again at 65 or 60 to 65% airflow, and you're going to select a speed tap for that normally open contact on the relay. Okay, so let's go ahead and talk a little bit through as far as some different things on this hookup. So right now I've taken all the text fields off, and you can see that's our basic block wiring diagram. Pretty straightforward, pretty simple. Now you'll notice that when we have an S1, if you take a look at the animation, let me back it up again. You'll notice that when we have an S1 output, when we have an S1 output from the outdoor unit, what the outdoor unit is doing at that point, it's energizing that relay. It's energizing the relay, and it's commanding reduced airflow, because what happens is it switches the relay. You'll see it switches the relay, and we are now energized the normally open contacts, and we're going to be calling for reduced airflow. So S1 outside, the outdoor unit, is actually what determines when we're going to switch the indoor airflow, because as it gets cooler outside and the unit starts to modulate down, the outdoor unit starts to modulate down, and it has less capacity because it's getting cooler and there's less demand on it, it'll go ahead and energize S1, it'll switch the relay, and then command reduced airflow inside to better match that capacity, that reduced capacity. Now, a couple things we want to keep in mind, that if W1 call is present, in other words, even if I'm in reduced airflow, if I get a defrost call, or if I energize the heat pump, let's say we're in the heating mode of operation, and I energize W1 auxiliary heat, if I get a W1 or auxiliary heat call, the fan will automatically go to high speed and S1 will have no effect. So let me say that again. If you should happen to get a W1 or an auxiliary heat call, or if a unit goes into defrost, what's going to happen, it's going to switch, it's going to put 24 volts on W1, and the ECM motor, it's designed, if it sees more than one speed command, it will always take the highest of those commands. And remember, we hooked up W1 to our high speed. So even if I'm calling for reduced airflow, if I get a W1 call, it'll switch it to high speed, and S1, it'll basically ignore that S1 call. Any questions or comments on that?
No.
Okay, good. All right. Well, fantastic. And again, just a quick reminder that W1 will be present, at W1 call for heat strips will be present with a thermostat auxiliary heat call or during the defrost cycle. Because remember, during the defrost cycle, the outdoor unit generates a W call to bring the heat strips on during defrost. Because remember, when we go into defrost, we're actually going into the air conditioning mode of operation, and we don't want to freeze the homeowner out. So we bring on the auxiliary heat inside to ensure that we don't have that cold air blowing through the ductwork and into the home. So remember, during defrost, we always bring heating on to temper that air or to keep that cold air from blowing into the home. Any questions or comments on the basic hookup of the AE air handler and some of the functions of that S1 and how the relay is operating? Any questions or comments on that? Everybody good? Everybody good?
Yeah, thank you, Joel.
Okay. All right, so let's go ahead and talk a little bit about this time. Let's go ahead and talk about hooking up a heat pump with a dual fuel furnace. So in other words, we're going to use, in this example, we're going to use a standard ECM motor again. And we have two furnace products that feature this. We have a TME furnace, which is a single stage furnace with a high efficiency blower motor. We also have what we call a TMY, which is a two-stage furnace with the same type of high efficiency ECM motor. So we're going to look at both of those because they're very, very similar. It's just that the TMY furnace has two heating terminals and the TME furnace only has one heating terminal. So again, the low voltage wiring of these two furnaces, we're going to look at a simplified block wiring diagram. And the TME furnace, again, is a single stage furnace, and the TMY is a two-stage furnace. Now we're going to be using that wiring, that wiring accessory, that single pole double throw relay in the indoor unit, just like we did on the AE air handler for airflow reduction. Now remember that 001 kit, that HMH7AK001 kit is going to be recommended for convenience and supplied parts. Let me stop there for just a second. We've had contractors ask before during our training sessions, well, gee, Joel, I've got my own bi-flow filter dryer in my truck. I don't need that kit for that. That relay, it's just a single pole double throw relay. Could I use just a single pole double throw switching relay or a peanut relay? Because I've got lots of those on my truck and I've got my own bi-flow filter dryers. Could I make up my own kit? Well, of course you could. If you just want to take a peanut relay and hook it up like we're showing here with a single pole double throw action, as long as it has a 24-volt coil on it, control voltage on the coil, and you've got your own bi-flow filter dryer, go ahead, you can do that. You don't have to buy this kit, or if the kit's not available, or our local wind supply, maybe they're out of those kits or whatever. Could you still put this in with just a regular switching relay? Absolutely. Could you put on your own bi-flow filter dryer? Well, of course you could, but now you'd have to make up some wiring. You'd have to make some wiring up inside the air handler or the furnace. Just remember that. But yes, you could use any generic single pole double throw relay with a 24-volt coil and put your own bi-flow filter dryer in there. However, we do recommend this kit 001 or 002 for convenience and supplied parts, because it all comes in a nice little package and a nice little kit. And so we recommend that for your convenience. However, if you needed to, or if you had to, or you just wanted to make up your own kit with a single pole double throw relay, just a little peanut relay, and your own bi-flow filter dryer, of course you could if you need to. Any questions on that real quick?
No, I think we're all good, Joel. We have some questions come up soon.
Okay, that sounds real good. Okay, and then again, Tame, remember, if you're going to be hooking up this heat pump to a gas furnace inside, you're going to have a heat pump. It's got that BO selection. Remember that BO selection for reversing valve operation. And you're also going to select a heat pump thermostat with dual fuel function with the furnace product. Now, let me stress that again. The heat with the furnace, you have to have a heat pump that has dual fuel capability. And so be sure that your heat pump thermostat that you're selecting has got the BO selection for reversing valve, but also that it has the capability of dual fuel operation on the furnace. So as we take a look at it, we're going to take a look at our TME single stage furnace, and you're going to notice that this looks an awful lot like what we just did on an AE air handler, because it's very, very similar. It's just the terminal designations have changed slightly. Now, please remember, Tame, a dual fuel thermostat on a furnace. So just like we had before, B terminal is going to go straight through from the thermostat, the 24-volt heat pump thermostat, to the outdoor unit. Now, because this is a single stage furnace, we're just going to use a W1 terminal, the W1 terminal, from the thermostat over to W terminal on the furnace, because it's a single stage furnace, and then we'll go outside to the W terminal outside. Because remember, team, during defrost, we have to have that output from the outdoor unit to bring the heating on during defrost so we don't freeze the homeowner out during defrost. And just like we had before, Y is going to be our compressor call, and that goes straight outside like we talked about before. Now you're going to notice something, that on the TME furnace, there's going to be hard physical screw connections. So these aren't pigtails, they're going to be screw connections on the control board. So that'll be a little bit more convenient as you take a look at this block diagram, remembering that the furnace has actual screw connections for your low voltage wiring. C is our 24-volt common, just like we had before, and that's typically a blue wire that's utilized, but of course the contractor can use whatever color wire he wants inside of that low voltage wiring harness. R is 24-volt hot, just like before. Now please remember, team, the R does not go to the outdoor unit, even on the furnace. It does not go to the outdoor unit. B is going to be our fan call, just like we had before. And you'll notice that on the TME furnace, we've got some designation, or more specifically, some terminals for Y1 and Y2. And we're going to talk about those here shortly. Okay, on the relay, one side of the coil, in this example, we're utilizing the B terminal, but one side of the relay coil goes to S1, just like we had before. The other side of the coil, the relay coil, is going to go to common, just like we had before. So remember, team, S1, when S1 energizes outside, it's going to switch that relay, is going to cause that relay to electrically switch. So one side of that coil goes to common, the other side of the relay coil goes to S1. Just like we had before in our previous slides, the common switching terminal for the switching relay, the common terminal there goes to Y terminal. And so what that's going to do, that'll give us the opportunity to energize or have 24 volts. Anytime we have a call for compressor operation, it's going to have power to that common terminal. Now you'll notice, again, I want to stress from the thermostat, we go straight outside. And so the relay itself is going to be switching Y1 and Y2. So I just want to make sure everybody's clear on that. We go straight outside with the Y terminal from the thermostat. We make that connection for the relay. And then let's take a look at those relay contacts now. We'll notice that the normally closed relay contact goes to Y/Y2 on the furnace. And remember, team, the furnace actually has physical hard screw terminals that you're going to make these connections on. So your normally closed contact is going to go to Y/Y2 on the furnace. The normally open contact on the relay, is going to go to Y1. So you'll notice that normal operation right now, without the relay energized, in other words, we don't have an S1 output from outside, the relay is not energized, it's just sitting there. If I get a call for cooling right now on Y terminal, it's going to bring on Y/Y2 high-speed airflow, 100% cooling airflow. If I switch that relay to the normally open contacts, it'll energize Y1, or in other words, the low airflow, the 60 to 65% airflow. So please keep that in mind. The normal operation with the relay de-energized is high-speed cooling, and with the relay energized, that's reduced airflow, 60 to 65% airflow for the reduced airflow when it's commanded. Any questions or comments so far?
No, Joel, I think we're all right.
Everybody good?
Okay, yeah, we're good.
Very good. All right. Okay, so let's take a look at the TMY furnace. Now remember, team, the TMY is a two-stage furnace, Now please note something. The low voltage wiring and the relay wires up exactly like the TME single-stage furnace. The only exception is the TMY is a two-stage furnace and requires a W2 and a W1 terminal. That's the only difference. So everything wires up exactly like we had before, except the W1 and W2 on the TMY furnace, because it has two heating terminals because it's a two-stage furnace. So let's take a look at that. So everything's wired up just like we had before. Very, very simple, very, very straightforward. But we'll notice on this furnace, because it's two-stage heating, W2 from the thermostat goes to W2 on the furnace. So W2 from the thermostat, second stage heat, goes to W2 on the furnace, which is second stage heat. W1 on the thermostat goes to the W/W1 terminal on the furnace, and then that goes outside to W. So other than those two little examples, because we have two W terminals on a two-stage furnace, everything else is exactly like the previous furnace that we looked at. So W2 goes to W2, W1 from the thermostat goes to W1, W/W1 on the furnace, and then that goes on outside to W. Any questions or comments on how that there's a very, very slight difference of the two furnaces and how we hook that up? And then we'll go ahead and we'll look at an animation and any questions?
No, it looks good, Joel.
Okay, fantastic. So at this point, let's go ahead and take a look at that animation. And let me back up and show it to you one more time. Watch the PowerPoint closely. So if the outdoor unit calls for reduced airflow, it energizes S1. It switches that relay. And notice that S1 input from the outdoor unit switches that relay and commands reduced airflow. So that's how that works. So the relay, the big thing with the relay, team, is the fact that that relay is going to switch and go to lower airflow whenever the outdoor unit starts reaching a lower point of capacity. Now remember, the outdoor unit's a modulating unit, but it wires up like a two-stage unit, right? So really, if you look at it, it really wires up like a single stage unit with just a single yellow wire going outside. So it's very, very simple to hook up, but the outdoor unit makes some intelligent decisions. And then we use a relay inside to switch high airflow to low airflow when we want to command low airflow. So the outdoor unit is very, very smart. It knows when it needs reduced airflow. As it starts modulating back on a mild day, it'll then switch that relay and give us lower airflow inside during those reduced capacity days. Any questions or comments on any of the low voltage wiring before we talk a little bit about airflow considerations on our HMH7 17 SEER heat pump? But before we move there, we'll go ahead and take any questions you may have on the low voltage wiring. Any questions or comments?
Okay. Okay. The question is, how can we have a furnace?
This is the dual fuel. We're good, Joe.
Okay, that's what I guess. That's what
Everybody good?
Okay.
Everybody good?
We're good. We're good.
Okay,
Yeah,
fantastic.
we're good.
Okay, fantastic. All right, team, at this time, let's go ahead and take a little bit of a look at some airflow considerations. Now, remember, because this is a modulating unit, it's going to be very, very important that we have the proper airflow. So please remember on every install to confirm your proper airflow. Remember, we want 400 CFM per ton of cooling. So if we have a 3-ton unit outside, we need a duct system that'll handle 1200 CFM. If it's a 2-ton unit outside, we need a duct system that'll handle 800 CFM and so on. So the HMH7 is a modulating capacity unit, and nominal airflow is critical. And again, we want to stress that ductwork has to be sized to provide 400 CFM per ton of cooling capacity. The other thing we need to really think about, because this is a modulating unit, we want to make sure that we've got the proper airflow going down the ductwork, but we also want to remember that manual D, that's kind of the Bible, if you will, for residential duct systems. We're going to make sure, we want to make sure that we do not exceed the recommended velocity, because remember, if the air is moving too fast across that indoor coil, especially on a modulating unit, if the air is moving too fast across that indoor coil, what's going to happen? You're not going to get good heat exchange. And if you don't have good heat exchange, what's going to happen is the outdoor unit's going to perceive that as a change in capacity or a change in load on the house. So it's real important that we have 400 CFM per ton. But it's also equally important that we make sure we don't have the air moving too fast across those coils inside or too slow. So remember, if the homeowner wants to use like pleated filters and things like that, please take that into consideration whenever you're designing your ductwork, because remember, we want to not only have the CFM, we also want to have the velocity or the speed of the air going across that indoor coil according to manual D. So this is a real quick little table that you can look at. This is right out of manual D, which is, like I said, the kind of the Bible, if you will, for airflow, for residential airflow and duct design. And so this table's right out of manual D, ACA manual D. So as we take a look at some of those considerations, remember that on the main trunk, that's your main trunk, the recommended velocity, the air velocity going down that main trunk is 700 feet a minute, not to exceed 900 on the supply, and 600 on the return, recommended not to exceed 700. All of your branch ducts, we recommend 600 feet per minute on your takeoffs or your branch runs, and do not exceed 700 on your supply branch runs. On your return branches coming back, a manual D recommends 400 feet per minute is recommended for your return branches if you have multiple returns coming back, not to exceed 600. On your registers, we like to see 500 feet per minute. This is what manual D recommends on the supply, not to exceed 750. And on the return registers, you don't want to see any more than 400 feet a minute velocity going across the face of that return, and 600 is the maximum, and so on. The grills are going to be the same as registers. If you take a look at that all the way across, they're the same as the registers. Same way with diffusers. 500 feet a minute is recommended on the supply, not to exceed 750. Return is 400 and 600 on the return. Now, this is really, really, really important, team. If you have filters in the return, this is right out of Manual D. This isn't something I'm making up. If you have filters in the return, do not exceed 300 feet a minute velocity across those filters. And so we not only need the CFM, but also we find out that the speed, according to Manual D, the speed or the velocity of the air through those main duct systems, main trunks and branch runs and registers and grills and stuff and filter grills is very, very important. Now, William, if you don't have a copy of this chart, I can certainly send this to you. Or anyone that looks at the training, please reach out to me if you want a copy of this chart. I've got this in a little PDF file that you can have and dispense if you want to. But these are velocity tables right out of VACA Manual D, and especially on a modulating system, any of our modulating systems, we want to make sure we not only have the 400 CFM per ton cubic feet per minute, the amount of air. We want to make sure we don't exceed these velocities as well, because that's really important with modulating systems like I had outlined a minute ago, to where if they see reduced airflow or if the air is moving too fast or too slow, that modulating system will view that or sense that as being a reduction or an increase in capacity, and then it'll have to modulate accordingly. So please remember that airflow is very, very important on any piece of equipment, but on modulating equipment, it's really, really important, because if we don't get that right, it'll keep the outdoor unit from operating within its design parameters. Any questions or comments on these airflow considerations before we start wrapping up our training for today?
Oh yeah, we're good. I have that table as well.
Okay, fantastic. Well, please, by all means, if anyone wants it or they desire that, be sure and pass that on to them if you would, please. And again, we've got copies of all this as well, if you need them. Okay, so let's go ahead and open the floor up for any general final questions or comments as we start kind of winding down our presentation for today. So we'll just kind of open the floor up. If there are any general questions, we'll give everybody a little bit of time just to think about that. And let's go ahead and open that floor up for any questions at this time. Everybody good?
Yeah.
Everybody good?
Yeah, he said he's good. Yeah.
Well, I'll tell you what then. Let's go ahead and we'll go ahead and pop the screen here back, and I'll get my camera back. See my smiley face with everybody.
There you go.
All right. Well, I want to thank everybody. Thank you for today. And so, if there's no final questions or comments,
Yeah. No. Thank you, Joel. We got, I don't know, Ron just had to come in. We had a few technical issues